Heat is the biggest enemy of all electronic components, and your CPU generates a lot of it. That's why processors require a dedicated cooler. CPU coolers play a crucial role in maintaining normal operating temperature, preventing thermal throttling, and extending the lifespan of your CPU. While the cooler itself can directly improve the performance of your system, it helps more powerful CPUs maintain higher performance for extended periods of time. CPU coolers are divided into two main categories: air coolers and liquid coolers. Air coolers use a heatsink made of metal and one or multiple plastic fans to dissipate the heat. Liquid coolers, on the other hand, use a closed-loop system with coolant and a radiator. Air coolers come in several variants: passive coolers, top-down coolers, and tower coolers. Passive coolers feature only a metal heatsink, usually made out of solid aluminum, with large number of fins. They rely solely on natural heat dissipation without fans, making them ideal for low-powered systems where fans would unnecessarily increase power consumption. Additionally, they are completely silent. However, passive coolers require more surface area compared to active cooling and is unsuitable for more powerful CPUs. Top-down coolers are often the stock option included with box CPUs, but many aftermarket solutions are also available. These coolers typically use a heatsink combined with a fan that blows towards the CPU and the motherboard, aiding the heat dissipation. Heatsinks can be made of aluminum or include a copper plate for faster heat transfer. Pure solid copper heatsinks are rare due to their weight and high production cost. Instead, heat pipes, usually made of copper and sometimes nickel plated, are preferred for efficient heat dissipation. High-end coolers often include these pipes. You might also see the term low profile, indicating that the cooler's height is compact enough for smaller form factor cases. Depending on the model, power ratings may range from 65 watts up to 150 watts. Tower coolers typically feature multiple heat pipes extending perpendicular from the CPU, with one or more aluminum heat sinks and fans attached to the pipes. This design allows heat to dissipate faster from the CPU and escape more efficiently from the PC case, as the fans generally pull cool air from the front and expel it from the rear. Tower coolers usually have a higher TDP rating, ranging from 150 watts to over 250 watts. Liquid coolers use liquid to transfer heat from the CPU to a radiator, which dissipates the heat using fans. The liquid, usually deionized water, has a much higher heat capacity than air, allowing it to carry away heat more efficiently and handle sudden CPU power bursts with ease due to the thermal inertia of water. This capability makes liquid coolers ideal for high-performance CPUs and overclocked systems. They're also often quieter because radiator fans can spin slower while maintaining effective cooling. Liquid coolers sold on the market are often referred to as AIO because they come pre-assembled in a closed-loop design, making them easy to install. They're available in different sizes named after the fan sizes they use, with typical power dissipation ranging from 150 watts to over 300 watts, depending on the model. Choosing the right cooler for you depends on several factors: the TDP of the CPU, the size of your PC case, noise level preferences, your budget, and personal priorities. Passive coolers are mainly designed for low-power systems. While a few options exist for high-power processors, they're expensive and offer inferior cooling compared to fan-equipped alternatives. Use cases include environments requiring absolute silence or heavily dusted areas like workshops, where fans would stir up the dust. Top-down coolers are generally the most budget-friendly option. They provide basic heat dissipation but often generate noticeable noise due to their smaller high RPM fans. Choose them if you need a standard cooling and want to save some money. Tower coolers are an excellent choice for high-performance CPUs where overclocking is not required. They're relatively easy to install, highly reliable, and capable of functioning reasonably well even without working fans, making them suitable for systems requiring high reliability. Liquid coolers are the best option for scenarios demanding the highest cooling performance. While they offer exceptional cooling, They require proper installation to avoid premature failure. Liquid coolers are more expensive upfront and may involve additional long-term maintenance costs. Their installation, particularly for custom loops, can be complex for beginners. Moreover, they carry a small risk of leaks, which could damage critical components, and the pump may fail over time. Modern protections minimize the risk of CPU damage, but a failure could still cause system downtime. Thank you all for watching. Remember to give the video a thumbs up if it was helpful, and consider subscribing to my channel if you want to see more interesting videos. See you soon!